Okay, so we're going to first look at the exact Bayes theorem applied for classification. Okay, then of course this is not the method that we're going to be using when we actually go to SAS Enterprise Minor, but what we're going to be using there is naive Bayes. But before we get to naive Bayes, we need to understand how to apply the exact Bayes, and then we will see how what assumption we're going to relax. So in this example, we are looking at a target variable of whether the financial reports filed is fraudulent or truthful. Okay. And we have two predictors, company size, and the company size has two possible values, and then a second predictor. There are two predictors now. The Bayes example that we saw, the Bayes theorem example, we had only one predictor, which was just V, sorry. So now we have two predictors. So predictor 2 is whether the company has had prior legal trouble, yes or no. Okay. So the data is here. There are 10 companies. We have two predictors, okay, and the target is whether the financial report is fraudulent or not. So let's say this is, we'll use the letter F to indicate fraudulent and T for truthful. Okay, and there are two predictors, and the first predictor is company size, and we will use, and there are two possible values for company size. So this is L and small, and prior legal trouble we will use Y for S and N as no. Of course, we are keeping the example simple here. There are only two predictors, and each predictor has only two possible values. So the total combination here, the predictor profile, there are only four possibilities, right? There are only four possible cases. But of course, if you have 5 company sizes and 10 or 3 possible prior legal trouble, then you're going to get 15, 5 times 3, 15 possible predictor profiles. So now we have only 4, and that's because we want to keep the example simple. So we have L and N. Okay. So company size L, no prior legal trouble. Okay. So that's one predictor profile. Then L and Y, that is the second predictor profile. And then small and no prior trouble, small and yes for prior trouble. So there are 4 different cases of predictor, as opposed to we had just one in the example that we saw for Bayes theorem. So which means that we have to do 4 different computations. For each predictor profile, you have to develop a Bayes theorem computation. So let's look at the PowerPoint file. So we have 4 different predictor profile cases. So now we have to have prior probabilities and conditional probabilities, and then you multiply and apply the 4 different cases of Bayes theorem, then we'll have the probability. Okay, so let's look at how this is done in Excel. So let's take one case at a time. Okay, so case 1. Okay, so predictor profile is that one, L and N. Okay, so again we start with prior probability. So what is the prior probability of F and T? So here we can, there are only a few records here, it's no big deal, so we can just count how many. So here we know that there are 4 out of 10 are fraudulent and 6 out of 10 are truthful. So we can simply type in 0.4 and 0.6. Okay, it's possible to do it that way. Okay, but if you have lots of records, not 10 but 100, then you want to be able to have a condensed summarized table, and then we can use the numbers from the table to build these probabilities, right? And how can we do that? Well, we can use pivot table of the data, and let's put the pivot table right here. So joint frequency table, all right? So then the target goes as columns, all right? And then we will put company size and prior legal trouble, like that. Okay, so then we bring in any of the non-numeric variable, then you get the count. So now we have the count of all the different combinations right here. So now we can use this table to set up our probabilities also. Okay, so if you have this table, then our prior probability of P of F will be, so this column, the total is 4, so H14 divided by J14 will give you the prior probability of F, and I14 divided by J14 will give you the prior probability of truthful. Okay, so those are the two prior probabilities. Okay, so now we want the conditional probability. So conditional probability is what? Conditional probability is given F, so the probability that we want here is, okay, let's look at what that is. Okay. So that one will be probability of the predictor profile given F. And what is the predictive profile that we are looking at in this particular case? It is L and N. So probability of L and N given F. And then truthful here, L and N and truth. Okay, so that's what we want here. Okay, so again, in a small data set like this, we can actually go and count it. So given fraudulent, so which means if you look at only these 4, given fraudulent, so now you're slicing it to just these 4 observations. Okay, the predicted profile is L and N. So L and the N is, how many are there? Out of 4, just 1, right? L and N is So you can type in 0.25 here. Okay. But of course, if you have a large database, then you have to use the summarized version of the table, the pivot table. Now you are looking for fraudulent, so it is this column. So now you're going to only look at this column. Out of this column, which is 4, how many are L and N, which is that? So it is H9 divided by H14. This would be, so that will give you the conditional probability of the predicted profile given F, and same thing, predicted profile given T, so which will be the same thing from this column. So instead of H9 and 14, it will be I9 over I14. So that will be the conditional probability. Okay, so now we have everything we need to find the posterior probabilities, and that would be the conditional probability times prior probability will give you the joint probability, and you do the same thing here. Then you sum. That will give you the probability of the predicted profile. Okay. Now divide that into the joint probability, and you get the posterior probability. Oh, I forgot. I need to make that absolute reference. Put the border back. So now these are our propensities for the predicted profile L and N. Right? Okay, so now we have to repeat this for the other predicted profiles. There are totally 4 predicted profiles. Now we have to do this for each of them. So the joint probability should be conditional probability times the prior probability. So that's the formula, and then you copy that down, and when you sum, you get sum these two, you get the marginal probability for the predicted profile, and then you divide that into the joint probability and you get one. That should be